Well, it started out simple enough. I just wanted to do some Ceph testing, long-term performance evaluation of these Memblaze drives that I reviewed previously, the P-Blaze 7, 7A40. But the real world plan doesn't survive contact with problems. Ceph and Proxmox is a big deal. It's come a long way in the last year. Things have taken a turn here, and the anecdote is, don't run Ceph on consumer NVMe. It's like, this is TLC Flash, this is TLC Flash. I thought that'll be a good comparison. Surely you can run Ceph on consumer Flash a little bit. I'd intended for more enterprise drive comparisons like Memblaze and Kioxia and Samsung enterprise class drives, maybe even some Solidigm class enterprise drives. But just for fun, let's throw in some consumer drives, the Solidigm P44 Pros, because these were the best of the best consumer drives. They're better than a Samsung 980, and they're TLC. What's not to love? That's where I went wrong. This whole thing has been a complete disaster and a mess, and none of my assumptions really survived contact with Ceph. This whole thing has turned into a black hole of time and suffering and pain, and I just want to compare and contrast. Like, what is the Ceph experience like? Do we have vSAN style hyperconvergence? The answer to that is resoundingly no. But I do want to ask questions, and I do want to see Ceph performance tuning, and I do want to see what people that are using Ceph and, smallish clusters where that's like 5 or 5 to 7 nodes, and create a surprisingly accessible set of recommendations and parallel test setups. At the same time, I've also been wondering, it's like, have we answered all the questions on clustering and fabric workloads and are you doing a video on XYZ? I mean, I'm sure that Memblaze certainly wonders. It's like, they talk to me about how their customers are using Ceph and distributed storage. Now, if you're not read in on Ceph and distributed storage and all this kind of stuff, there's OSDs, object storage daemons. There's a lot to that. But basically, you have a storage node and you have a network of servers, and the servers take all of their storage and present it as one pool. Ideally with Ceph, the throughput and the latency is roughly the same, and because of that architecture, it's absorbed in the background. Ceph doesn't just use a drive. It uses a few OSDs and a placement group to figure out where the blocks go, and this becomes part of the critical path, and so that's all been a voyage of learning and discovery for me. But when you have drives that behave inconsistently, you don't just get uneven performance. It turns into uneven placement groups, which turns into bursts of tail latency that feel like the whole cluster is haunted. Because it's like, I'm going to copy a few small files, boom, it completes. I'm going to copy a few small files in my Windows VM. The whole cluster hangs. Replicas, okay, one laggy OSD can drag the whole write path down even if the other replicas are fine. This felt a little bit like a Ceph architectural thing, and maybe a me problem from running this only on 4 nodes. You would also think things like the closest drive is also the lowest latency, but the P44 Pros were struggling with write latency. So depending on how your pools and your clients are configured, you can see cases where a remote OSD, the one servicing the reads, is actually faster than the local drive that is failing. The remote wins. An important note here, I'm not claiming that Ceph is some magical mechanism for dealing with that kind of thing. ZFS seems to. Like, ZFS in my experience would say, oh, this drive is doing something weird, or it's unusually slow. It'll get kicked from the pool. But your OSD replica set in Ceph, it's like the bad local OSD sort of becomes the limiting factor. But it was hard to ferret out, like, which P44 Pros were suffering. So I might have a group of 4 or 8 in a particular machine, because I bought 24 drives total just to see, a while ago, and that was sort of fun. So when ops take a long time, Ceph doesn't think they're complaint worthy until it's about a 30-second threshold. It's OSD op complaint time. And there's an OSD operation thread, OSD op threshold timeout. And that's commonly documented in the 15 to 30 second range, depending on the distro and the documentations. But slow is not the same thing as dead. And Ceph will typically mark an OSD out when it's completely down, i.e. the heartbeats stop, on the order of minutes. By default, the duration is 600 seconds, which is 10 minutes. And they also sort of get hostile if you want to change that. There's OSD op timeout. I mean, Ceph's guidance is basically don't touch any of this unless you understand the consequences, because clients can interpret it like it's a hardware failure when really it's just a write pressure stall or something like that. So the takeaway here is that Ceph will tolerate slow longer than you expect because it's engineered to survive transient slowness without ejecting OSDs, and that's great for distributed systems. But all of this is because consumer drives, right? Is that because that's the rule? That's the thing. It's like, don't use Ceph on consumer drives. No, it turns out the P44 Pros have a firmware bug. The firmware bug is what I was tripping over. As I was working on this the last few months, there's some other power users that showed up in our community that came forward with poor performance with their P44 Pros as well. And there's a fix, and you can reformat the drive, well, sometimes, and trigger the issue. It seems like it's a problem with the SLC write cache on the P44 Pros never actually getting cleared, and I sort of had to work backwards to get there. This would certainly cause some of the kind of problems that I was seeing, but I was also seeing drives drop out with smart errors, is prematurely wearing out the SLC cache. I've had to return 2 drives for RMA. Ceph is sitting here watching this, and it's like, oh, I'll just let that drive burn out before actually sounding the fire alarm, which is not amazing. So let me bring this back to Memblaze. These drives have been a joy to work with. There are consummate professionals. As I said, I have peppered them with questions like, are people using these for Ceph and at scale? And yes, and we're talking 10, 20, 30 node Ceph clusters. And so they were very tolerant of my questions, and they were very tolerant of sharing data on how they use at scale. And I was able to deploy, 9 of these across 4 machines to see how it would work and to see how, the enterprise side of things works. So it's not just TLC versus TLC, and it's not just firmware for firmware. I tripped over some pretty severe P44 Pro bugs. So I sort of expected that the TLC scenario with these P44 Pros would go okay. But running database workloads and VDI setups and everything else like that on our Memblaze setup actually worked really well, surprisingly well. So I've got this split brain thing going on where it's like, oh, this was so good, I actually like Ceph. And then it went so completely wrong on the P44 Pro side with the entire storage pool crashing, not once, but twice as I was doing this. So this is important if you're using Ceph for storage and Proxmox. If you have a VM for, a database or storage or consistent behavior, this storage stack spread across these machines makes a huge difference, especially when there's little problems where the drive doesn't respond in a timely fashion, but also doesn't error out. You really don't want any extra latency, and you really don't want the bizarre situation where the remote storage has better latency than local storage because local storage happens to have a drive that is struggling. Another thing, 4 machines really isn't enough for a true Ceph cluster. In my case, I think it amplified some of the squirreliness with the as yet undefined Solidigm firmware problems. Even when I was using 3 replicas of the data, which basically meant you're just dealing with local, like there's a local copy of all of the data. But it didn't necessarily choose the correct local copy when I was having problems. Now, I don't have enough Solidigm Enterprise class drives to do a proper comparison, and this is not really fair to Solidigm. You shouldn't take this completely as a Solidigm screwed up here. Solidigm Consumer screwed up here. Solidigm Enterprise should behave more like this, but I don't have enough enterprise Solidigm drives to do some sort of grudge match or shootout on this side of things. And to Solidigm's credit, the unclean shutdowns and other things like that I tested did show up in the smart error reports, and smart error reports also reported on the 2 drives that I actually had to have RMA'd. So yes, clustered storage and unclean shutdowns is not good. You will lose whole storage pool accesses, like the whole storage pool across all servers will go down if you just have a couple of servers go down and you're just unfortunate. So I think a cluster comparison among 3 or 4 different enterprise brands is in my future. I've only got this one because this has sucked up an insane amount of time, but the Memblaze side of things has been rock solid. But the consumer P44 Pros went so catastrophically wrong, I feel like that, yes, there is quite a lot of wisdom in the old Ceph anecdote, don't use consumer drives. And I really was not expecting that, but I'm also maybe reading a little too much into it because maybe some consumer drives would be okay in some scenarios because what I exposed here was a P44 Pro firmware bug. The write SLC problem exists and it is real, and as far as I can tell, Solidigm has not fixed it and doesn't really care. They have been replacing drives under warranty with new drives, so I mean clearly they have stock or something like that, but I have not seen anything for a firmware update on an ICDoc, ICDoc directly to the forehead. ICDoc sent me a bunch of these 24, and I've been using these U.2 to M.2 adapters, not just for Solidigm, but also other configurations as well. And these have been working even at PCIe Gen 5 speeds, for me anyway. So that's exciting and that's a lot of fun. But I have this Ceph cluster, I have 4 machines set up, and they're good to go with enterprise class drives. What sort of testing and configuration do you need to see? Also tested this at 25 gig. I definitely would not recommend a Ceph cluster of any size at less than 25 gig, and 100 gig actually would be better than 25 gig. Let's just, Ceph really, like 7, 8, 10 hosts or more pool of storage. Otherwise, really, ZFS replication is where it at. And ZFS replication is not the same as hyperconvergence. It's not a vSAN. They're not at all the same. Got some other videos on that. This is sort of the month or two of Proxmox and Proxmox adventures. If you're just getting into Proxmox and you're going down the rabbit hole and looking at this kind of stuff, this is your warning that yes, there is some validity to don't use consumer drives for Ceph. The other common failure mode with consumer drives is when they lose power differently than these drives. These drives will be much more coherent. They have internal power loss protection, which works great in a power loss scenario or hard server crash scenario, so that these things can get the information that was stored in the buffer written out. So I guess the question is, where do we go from here? Well, we've learned some important lessons. And okay, best case scenario, the people that have the P44 Pros, Solidigm actually does, haul the firmware engineers out or rehire them or whatever, and we get a firmware update for the P44 Pros. Even if the P44 Pros were working perfectly correctly, I still don't know that I would recommend consumer grade drives, and the reason is because we learned that if one of these drives has any little hiccup, any little hitch, any little like, oh, I'm sorry, hang on a second, let me do something, the entire storage array could hitch because your storage is distributed across a whole bunch of hosts. And this maybe exposes something with like Ceph and Ceph engineering, because I would like for Ceph to have a really quick timeout, especially when we're working with things that are like 25 gig, because there are aspects of Ceph that literally do not work correctly at less than 10 gigabit. And at the same time, when you're dealing with, flash-based storage, when you have latencies going into the, hundreds of milliseconds, it doesn't seem to mind that. And so maybe there's some engineering stuff to deal with that. But when you're testing enterprise grade drives, then a lot of those problems don't happen, and maybe it's not really an engineering thing. So, coming from Ceph at scale, when we're talking about like a petabyte of mechanical storage or 100 terabytes of flash, Ceph I still think makes sense spread across a whole bunch of hosts. The enterprise class drives are all really hardened. They have a lot of stuff that has gone into the firmware, and there is Ceph performance stuff on the forum. First for Memblaze, which is doing the best for Ceph and Ceph clustering, even with relatively small clusters. But then I experienced all this, and I felt like it's a cautionary tale of warning, and there is something there. And there's also something there is something with the firmware here, which hurt my ability to do the video, to do the comparison for consumer drives, and there's not really enough time to talk about the nuance and subtlety of that, along with, hey, let's check out and see how Ceph is doing in a Proxmox context. So where does that leave us? Going into the next video, more Ceph testing with more different brands of drives across smallish, 3-ish node clusters, but bearing in mind that it's a full replication type setup. I might be able to scrounge together enough stuff to do like a 7 or 8 node cluster, but this is something we need to discuss in the forum, and especially after talking with other folks that are using Ceph in the enterprise and hearing from you, the community. And what I've encountered is this atypical. Have people experienced just catastrophic Ceph failures and that sort of thing? But also, this is a Gigabyte MC13 LE3. This thing has built-in 25 gigabit. It's epic. I've got 8 lanes of MCIO here, so I can go out to 2 Gen 5 M.2. That also leaves me 8 lanes here. I've got a M.2 here for my boot drive. This will make a pretty good platform for Proxmox for up to 16 cores. 16 cores on our AM5 Epic platform and 128 gigs. In these tumultuous times with unavailability of literally everything, I think that folks are really going to look at what their local compute needs are, and we might see a lot more deployments of this. And so like 3, 4, 5 of these in a cluster with Proxmox, that could be an interesting video. I don't know, but like engage, let me know what you want to see, or if you're running something like this already, what your experiences have been. That's where we go from here, because yeah, or maybe something other than Ceph. Maybe I should be looking at, DRBD or LinStore or something like that. Anyway, yeah. that's enough for this one. If you get the P44 Pro, sorry, firmware probably affects you even if you're not using Ceph, but wow, the impacts to Ceph from a flash drive slightly misbehaving. It's not non-functional, it's just weirdly slow for writes. It's slower than it should be. Anyway, I'm Wendell's level 1. It is what it is. Isn't that kind of the computer janitor's mantra? I'm signing out. You can find me in the level 1 forums where we really should discuss further and see how that shapes the next round of content around Ceph and Proxmox. All right. So like this is kind of a pre-game video, I guess. I'm sorry, but also it's interesting. Like there's hard-won knowledge here because of human suffering. That's how it goes. All right. I'm signing out and I'll see you there.